Good morning, everyone. Welcome to the inaugural GDS webinar series. Thanks to everyone for registering, getting through that process. Obviously, if you've made it to here, that means you got through that process. You're able to follow the links and create a Zoom account and do everything there. It's pretty good technology that's allowed us to do this. So, yeah, appreciate you spending the time to register and participate and listen in to the presentation that we're going to do today. So this is the first one that we have done of these. It's the first one I've done personally of these in terms of the webinar format. So hopefully it goes well. Hopefully all the internet gremlins stay away and we get through unscathed. So yeah, again, thanks for participating and being involved. So the idea of these webinar series is to be educational sessions. They're not a big, the idea is that this is not to be a sort of a product push. It's an educational sessions that we want to run through the winter months. And they're just short, sharp sessions. So the plan is to run them possibly weekly on a Thursday each week at 11:30 a.m. And they just go for 30 minutes. So just short, sharp 30-minute sessions. Don't want to take up a lot of your time, but if we can just get these regularly going, we'll bring in speakers from outside our organisation, so it just won't be me every week like you. So we'll bring in experts in their fields to talk on a range of different topics that hopefully will be of interest to you guys. So being a webinar format, everyone is on mute and your cameras won't work either. It's a bit of a sort of a one-directional type of presentation format. It has to be that way, with 100-odd participants and attendees. We can't have like 100 cameras and people talking and dogs barking and all that sort of stuff. So it's a bit of a one-way kind of session. However, if you do want to ask any questions or make a comment, within your Zoom menu, there should be a chat button. And if you click on that chat and type something in there and send it to me, I get a little notification if I see that. I can click on that and might be able to answer your question that way. But if that's all too daunting, or if I don't see it, if that doesn't work out, feel free to just give me a call after the presentation. You can give myself a call, any of our GDS representatives. If you want to go through any of the information that we've spoken about in more detail, happy to chat. And I'll have my mobile phone number on the last slide of the presentation. We can chat more about this. As I said, we've only got 30 minutes. We can't get too heavy into things in this sort of format, but if you want to go further with it, that's not a problem. So my name is Paul Spencer. I'm the agronomist for Greenway Turf Solutions, and I'll be running today's session. What we're going to talk about today is the soil analysis and how to determine what soil amendments to apply once we've done a soil analysis and got the results back, and also what rates of application do we need to go at. So what we're going to do, we're going to initially go into why we perform a soil analysis, what's the purpose of it. We're going to pull the analysis apart in terms of what data is it presenting to us, what is that information. Then we'll go into a couple of the theories of how you interpret that data, and then ultimately how to make amendment recommendations in terms of what is the appropriate amendment: gypsum, lime, dolomite, organics, kieserite, all these type of things, and what rate to be applied, because that's ultimately what a soil analysis does. A soil analysis, it analyses what's in your soil, what's not in your soil, and it should give you a guide then of your applications. So what we're going to do today is go from the start to the finish in terms of soil analysis result is back. How do we pull it apart? How do we get some good information out of it? So this presentation is going to be a little bit of a technical one. They won't all be like that. As I said, hopefully we're going to run, continue to run these. We'll see how it goes over in a webinar format and go from there. So to kick off the series, I just got a little message there that said I was muted through the through that introduction. So hopefully I wasn't. If I was, then I apologise, and hopefully we can get started. Okay, so as I mentioned in the introduction, if you heard it, we're going to talk about understanding the soil analysis report and determining nutrient applications. So first thing we wanted to discuss is why perform a soil analysis. So ultimately, the reason why we're performing soil analysis is to create optimal soil conditions, and that is good soil structure, good drainage. If we have good soil structure, we're going to have good drainage. We're going to have friable, non-compacted soils. We're going to have economical use of applied fertilisers. We're going to have an aerobic soil profile, an active microbial population. So that's ultimately what we're doing. We're trying to create these optimal soil conditions that are going to ultimately grow better turf grass. Optimal soil conditions revolves around good soil structure, and all these other benefits then result out of having that good soil structure. So I've got a couple of diagrams here. I'll attempt to do some drawings. So ultimately, what this is showing is a picture of a sandy soil with poor structure on the left, and a sandy soil with good structure on the right. So what is being shown here, depicted in these diagrams, is exactly that. So we have good soil structure, we're going to have little aggregates. The soil is going to have little aggregates that create pore space, that allow water to move through, and that's what we got here in this bottom diagram and this picture on the right. If we have poor soil structure, then we've got more sort of this scenario where it's all just stuck together. The soil is stuck together. There's no pore space. It's not friable. It's all just like a brick. And ultimately, growing turf grass in that situation is going to be a lot more difficult than growing turf grass where you've got pores and you've got good drainage and you've got friable conditions and you've got aerobic soil profile. So that ultimately, we're trying to perform a soil analysis to create good soil conditions so our root zones end up like what we have in the bottom picture and the one on the right. It's also the blueprint to turf nutrient applications. So, what nutrients are required and how much, what sort of NPK ratio we might be applying. It's also to be a good environmental steward. So we're not applying something we don't need, or we're over applying any particular nutrient. So what does a soil analysis test for? It's not nitrogen. So, nitrogen is not the purpose of a soil analysis. Nitrogen is your job as turf managers. Only you guys know how much nitrogen your turf grass needs on a daily basis, on a weekly basis. So you control that part. What a soil analysis does, it looks at the major nutrients that balance the soil. So that is calcium, magnesium, potassium, CAMGK down here. We also look at Na, which is sodium. Well, it's not a nutrient. It is something we need to look at in soil analysis. So ultimately what we're doing in a soil analysis is we're setting the soils up for good utilisation of applied nutrients from fertilisers such as nitrogen. So when you apply your nitrogen, you get the best result from it. And we're setting up, the soils for success, basically, for a healthy plant and for effective utilisation of the end that is applied. So how do soils hold on to nutrients? Nutrients are positively charged cations, okay? So they have a charge and they're positively charged, and your clay and your organic matter are negatively charged. So in our soil, we have what's called these negative charges here, and we call those exchange sites. And this is a concept that we're going to talk a fair bit about today, so it's one that we want to make sure that we're fully all over, okay? So the soil has these negative charges. They're called exchange sites, and your nutrients that we apply, they're positively charged. So you can see in this case here, the calcium, magnesium, the potassium, they've all got a positive charge. So the positive charge of the nutrient attaches to the negative charge of the soil, and those negative charges are called exchange sites. You can see sodium just dropped down there, Na. Again, it's a non-nutrient, but it's positively charged. So we've got to make sure that we're keeping that as low as possible. So what are the essential nutrients, and what levels do they need to be at for a soil to be fertile? So if we have a look at the soil nutritional components, when we do a soil analysis, what nutrients are we looking at in the soil? Calcium should make up the majority. So it should make up 70% of our total soil nutrients. So when we're talking plant nutrients, we're talking N, nitrogen, P, K. They're all critical for the plant. But in terms of the soil, calcium is our most critical one. It should make up 70% of our total volume of soil nutrients, and it has a huge role in creating that soil structure. Calcium is what aggregates your soil particles. Calcium is what stimulates roots. Calcium is what feeds microbes, which help the soil structure. Calcium has a huge role both in the soil and the plant and should be making up 70% of our total soil nutrients. It's the one that really makes our nitrogen work. So if we get the calcium levels right and we get the soil in balance, then everything else kind of works out after that. Magnesium is the second most abundant nutrient at 15%. Potassium, really important plant nutrient, but in terms of soil nutrition, 5% is kind of what we're looking at. Then you got you got sodium in there, Na, which is what we want to keep as low as possible. We want to keep our salt as low as possible, and then then we have some other minor bases. But ultimately, this balance in the soil is called base saturation. So it's referred to as base saturation. So we're looking at 70% base saturation calcium, 15% base saturation magnesium, 5% base saturation potassium, and sodium under 3, trying to keep that as low as possible. And it's the balance of these that's the key to good fertility. So as turf managers, we're doing soil analysis. If we can achieve this balance, that's the key to creating optimal soil conditions, which are therefore going to grow good turf grass. They're going to perform well. They're going to have good oxygen levels in. They're going to move water, and they're going to support our plant. And the challenge for you guys really is to keep these essential nutritional components in balance. Because if we achieve that, we'll achieve that. So that's how those two things are interrelated. So if we can achieve this soil balance, we're going to get good soil structure. If we don't achieve this soil balance, then we're probably growing turf grass like this picture on the left, which is going to be a lot more difficult. To get water through there, to get roots down through there, to get a healthy plant. You're going to use so many more inputs growing turf grass on that soil on the left than what you're going to use growing turf grass on that soil on the right. So while they're not green soils, obviously the same theory is applied to a golf green, a bowling green, a sporting field, a tee, a turf farm, whatever it is you're maintaining, a racetrack. Those same principles apply. So what is in a soil analysis report? Okay, so this is a classic soil analysis report, one that we do, and it gives you a whole lot of data. So we're going to pull that apart. So here's that base saturation that we were talking about before. So this is depicted on the soil analysis. You can see in this case here we have an imbalanced soil. You can see that this is our ideal on the right-hand side here. If you can see the mouse, hopefully, the laser pointer on the screen. On the right there, that is our ideal balance. And then the soil test measures our actual balance. So you can see in this case, as I said, we're out of balance. We're not in a good situation in terms of soil balance, which is going to have an effect on the soil conditions and therefore the plant that's growing in it. This soil balance has a big impact on pH and really drives pH. So if the soil's in balance, like in this case, and we have heaps of this hydrogen and pH have a relationship, then we're going to have a really acidic soil pH, which is what we got here. Organic matter percentage is on the soil analysis. We want some positive humus in there. We don't want heaps of residual organic matter in there. We want some positive humus because it's those humus materials, fully broken down organic matter that are going to give us our exchange sites, those negative charges that we were talking about before. And that's what's on the soil analysis here. So this is that really key concept, which can be called a number of things. So on this soil test, it's called a total exchange capacity, or TEC. You might have heard it as CEC, which is a cation exchange capacity. So what that's trying to do, that's trying to measure or give you an estimate of how many of those negative charges we have in the soil. So it's trying to tell you your ability of your soil to hold nutrients. So if you go out there and apply some calcium, or apply some potassium, apply some magnesium, that number there tells you the ability of the soil to actually hold on to those nutrients. So low would be 1 or 2, medium would be around 5, 6, getting up there would be 10, 11, then you can go 20, 30, from there. In most turf situations, sand-based turf situations, I like to try to drive that towards sort of 6 or 7, if possible. So that's a key concept that we'll continually come back to as we go through the presentation. So along with the balance of the nutrients in the soil, we actually need to look at the actual raw concentration as well. And that's what's down here, the actual concentration. And that's measured in ppm, which stands for parts per million. So not only do we need the nutrients in the right balance, we actually need just enough of them in the first place to actually feed the turf grass. So that's two key things that we're looking at in a soil analysis. I've spoken about the balance heaps, but we actually need to make sure that we have enough of those nutrients in the first place to balance. And that's what we're looking at here. So you can see in this case, we've got 517 parts per million calcium, 95 parts per million magnesium, 67 parts per million potassium. Sodium, Na, we want to look at that. Obviously, we want to keep it as low as possible. So it's looked in the soil analysis. Phosphorus, key plant nutrient, so it's a critical one. And our minor nutrients, sulfur, boron, iron, manganese, copper, zinc. So that's basically what most soil analysis you get, what we'll show you. They'll show it in different terms sometimes, but basically that's the data we're getting out of soil analysis. So what are the nutritional targets that we're trying to achieve in our soil? What are we trying to achieve? You can see this is another soil analysis here. We're really low in all our key nutrients. You can see calcium here is super low, and magnesium is super low, and potassium's low, and even our iron and manganese. We have no organic matter percentage over here. Our total exchange capacity, our CEC, is 1.7, so that's really, really low. So they're all low, but what are we actually trying to achieve? What are the numbers? So the nutritional targets, they centre around providing all the components of fertility to support turf grass growth without affecting the desirable physical characteristics. So we need the desirable physical characteristics in our turf root zones. We need to be able to move water, we need to be able to move salts, we need to be able to maintain oxygen. But we can do all those things while still achieving the nutritional targets. So the nutritional components and targets are a large enough store of base nutrition. So I like to have 1,100 parts per million calcium, 140 parts per million magnesium, and 180 parts per million potassium. So that's a big enough store that we can then balance. And at those concentrations, we'll get the right balance in our soil as well. A CEC or a TEC around 6 to 8. An organic matter percentage close to 2% humus. So somewhere sort of 1.5, sort of 2% of actual humus. So humus is raw organic matter broken down. So we're not talking about residual organic matter. We're talking about after microbes break that down and turn it into humus, which doesn't affect your physical characteristics. And that's what we're looking to develop in our root zones, because that's going to give us our CEC in order to hold on to the nutrients. So that gives, as I said, exchange sites and biology. So you can see this is a classic soil analysis that really is deficient in most things. And this was from a golf green in Victoria, and you can see here we're sitting at very low levels of our calcium, again really low levels of our magnesium. Organic matter percentage is nothing, a TEC is nothing. And you can see here the sodium, as a result, is through the roof, 138 parts per million at 34%. And this is an actual photo of where that soil analysis was taken from. So this green was 1 year old. It was 1 year old. It had, as you can see there, it had black layer right at the surface. There was no water movement through the root zone. The plant was struggling using heaps of fungicides and so forth. So I've just had someone raise their hand on the chat. So if I can work out how to do it, I'm going to. Sorry, I'm a little bit of a novice at being able to work out how to. Sorry about that. I haven't been able to work out how to actually then respond. So if you have a question, maybe send it through the chat. Oh, here we go. We've got a few chat here. Yeah, no, everything's under control. Okay, so apologies. I haven't been able to work out how to work out the raise your hand feature. If I work that out, I'll try and answer your questions. As I said earlier on, I'll have my phone number at the end. If you want to call me and go through anything in any detail, happy to do so. But as I said, it's the first time I'm running this show, so apologies, I can't get that raise your hand feature to work. But ultimately, so this green was a year old. The soil analysis was really deficient in everything. Obviously, they didn't do one, initially, and it was creating a huge headache for the superintendent due to fungicides and heaps of materials being applied to try to keep this grass alive through summer, which all could have been avoided if the soil analysis was taken early on and we got those numbers up where they should be. Then that sodium wouldn't have had such a dramatic effect. So soil analysis interpretation. So how do we reach those targets? So we know what the targets are, in my mind, and they're the ones I've used over many years now and produced a very good result. So how do we actually get to those targets? We got a soil analysis which is really deficient in nutrient. How do we actually raise those nutrient levels up, and what number can we get out of that? So there's multiple theories and approaches that are out there in the industry, and unfortunately, some people say you've got to use this one, or you have to use that one, or you've got to use that one over there. And it's not really the case. It's actually knowing about those theories of interpretation and applying them at the right time, and applying them to your scenario and to your soil analysis and what you're trying to achieve. And that's what we'll go through here. So in our soil analysis, as I mentioned before, we're trying to achieve this 2% organic matter, hopefully. CEC, TEC around 6 to 8. Trying to have our nutrient levels up here at 1100, 140, 180, which will give us a really good balance as well. So we'll have a good balance plus enough of everything. So the two main approaches that you may have come across in the market is base saturation and SLAN. SLAN stands for sufficiency level of available nutrients. These are just both calculations, and they're calculations to try to give you an idea of how much nutrient you need to apply if you have a deficiency. And it's not a one or the other. You can use both, and that's what we'll hopefully sort of make clear through this. So if we have a look at the base saturation approach first, what it's trying to do is it looks at all the available exchange sites in the soil, so all those negative charges that we were talking about before. So that's the ability of your soil to hang on to nutrients. That's the ability of your root zone. When you apply a nutrient, how many of these negative charges are there for that nutrient to attach to? So it looks at the CEC, looks at all those, and then it fills them up, does a calculation to fill them up with all the nutrients in order to achieve this balance down here. So in this situation here, we got 40% calcium. We want 70% calcium. The base saturation approach will give you a calculation and give you a number to go from 40% to 70% to fill up those exchange sites in that correct ratio. So that's what it's trying to achieve. The SLAN approach doesn't consider that balance at all. It doesn't worry about that balance. All it's trying to do, you saw that little arrow fly down there. All it's trying to do is give you a calculation to go from what you have, say in this case 517 parts per million, to that number, to 1100 parts per million. It's giving you a calculation to go from there to there, from there to there, from there to there. So that sounds pretty handy. It sounds like a pretty good tool to be able to use. However, it does not consider how many actual exchange sites are there to hold on to that nutrient you might apply. So it doesn't consider the CEC, the TEC at all. So if you were using this approach and you got a recommendation and you went out and applied some nutrient, and you can see here, this is trying to depict that, we applied some calcium and some potassium and some magnesium, but we don't have the exchange sites to hang on to it, where's it going to go? Rhetorical question, of course. It's going to leach out. So it's going to stay in solution. It's got nothing to attach to. It's going to leach out through the root zone. So that's one limitation of the slant approach, especially in a turf grass situation, where we have a lot of sandy root zones which don't have a lot of exchange sites, and you apply all that nutrient, we're not going to achieve what we want to achieve straight up. It's just going to leach straight out. So that just means don't use the approach. You just have to be aware of that as a factor when writing your programs. So with the slant approach, we don't need really any of these things here. It doesn't look at any of those. It just looks at going from one number to another number. Ultimately, what these two approaches are doing is they're trying to give you a recommendation. They're trying to give you a application rate of a nutrient to apply. So you have a deficiency. So in this case here, we have a deficiency in calcium. As you can see, it's only at 36%, at 213 parts per million. We have a deficiency. So it's used the base saturation approach here to give us a number that we are 262 kgs of calcium deficient. So that's what we need to apply. So it's given us that number through the base saturation. So on a soil analysis, or on our soil analysis through the online website, it gives you that option here of which deficiency calculation you want to choose. So you can choose either the base saturation technique or approach, or you can choose the slant approach, depending on what's most suitable for your soil and what you're trying to achieve. So it's not one or the other. It's possibly and or choosing the right one for your situation. So as you click that button from base saturation to slant, you're going to get very different numbers down here. It's going to redo the calculation. So which one do we use is the obvious question out of all this in our interpretation. So there's a couple of there's some rules of thumb of when to use which one, and really this is the key to the whole presentation. Really, it's getting to this point and then determining which is appropriate an analysis interpretation to use. So use base saturation approach when that TEC or the CEC is greater than 5 or 6. Around that 5 or 6, when it's greater than that. When you have a soil imbalance, so when that pie chart is all mucked up and you have a soil imbalance, then a base saturation approach is appropriate. And when the pH is low, so when you have a really acidic pH. Then you use the slant approach when your TEC or CEC is less than 5. So you have a really low ability to hold on to nutrients. When the soil is in balance, but the concentrations are low. So we have a perfect pie chart, but we actually don't have much of anything. And when the pH is neutral or near neutral. So they're the two rules of thumb. Right, so this is where you guys get involved. And again, in a rhetorical sense, since we're doing this over a Zoom webinar. So there's a bit of information there. What we're going to try to do in this practical exercise is pull together that theory of what we just learnt in pretty quick time. And we're going to pull that information together to actually put it into practice and use some real soil analysis and go through the process of interpreting it and making recommendations. Okay, so this is our soil test interpretation number 1. So this is our analysis results. Give you a bit of time to look at that. So there's probably 4 main questions to ask yourself when you have a look. When this is presented to you, you have a look at it and go, what am I looking at? So 4 main steps to follow. Is there a soil imbalance? Number 1, just down here. Yeah, there certainly is. So this is our ideal balance saturation that we want there, and this is actually what we got in this soil test. Are there any nutrient deficiencies? Yeah, calcium is deficient. Magnesium only slightly, potassium's right on. Sodium is up. What is the CEC? What is the TEC? What's our, how many exchange sites we got? 6.4 in this case. What is the pH? Acidic, 5.7. 5.7 is quite low. It's quite acidic. So using our rules of thumb, once we've sort of asked ourselves those questions, which approach are we going to use in order to provide us with a recommendation of how much nutrient to apply? So we use a base saturation approach. Let's have a look at this one, go through the steps. So the TEC is greater than 5 or 6. So we're sitting here at 6.4. Yeah, so it's close. Yeah, so it's just above. When there is a soil imbalance, yes, we have a soil imbalance. So tick, tick. When the pH is low, certainly is 5.7. That's 7 is neutral. Anything below 7 is low and acidic, and 5.7 is a fair way below 7. So in this case, yeah, that seems a fit that we would use the base saturation approach in this scenario. Okay, so we've had a look at the soil analysis. We've chosen the base saturation approach. That base saturation approach has given us this number here. So we've clicked that button on the soil test, base saturation, and it's told us that we need 602 kgs of calcium because we're at 37% and we want to get to 70%. And it's telling us to do that, we need the 602 kgs of calcium. It hasn't given us too many other recommendations because everything else is pretty much in balance. So these are our available materials here. So there's more than these, but this is a pretty good cross section of what you'll get in the market. So we've got gypsum. So gypsum is 23% calcium. So it's going to apply some calcium. It's not going to have an effect on the pH though. We have lime, 34% calcium, but it's going to raise the soil pH. We've got dolomite, which has 20% calcium, 10% magnesium. It will raise the pH as well. TX10 has a concentrated organic that's going to give us some exchange sites, some humus if we need those. Activate K, that's a higher organic based again, giving exchange sites, but it's got a higher amount of potassium in it, so it's got high K greens fertilizer. Sulfix Mag, 18% magnesium, and TX Trace. So here's our available materials that we have that we might want to use to apply, given the soil analysis and given the recommendations. So what are you going to do? This is what I'll do. So out of those recommendations, I would, or out of those recommended materials, I'd firstly go in at lime. I'll go in with some lime because lime has 34% calcium, which is what we're deficient in, and it will raise the pH. So we'll start pushing that up a little bit. So we're going to rectify our calcium deficiency or part of it, and it's going to help our pH situation. So I'll do that over 2 applications. Then gypsum at 500 kgs a hectare over at least 3 applications. If we do 2 of lime and 3 of gypsum, we will actually address this 602 kgs deficiency. However, what I've written here is ongoing as well. So we wouldn't just stop at that. We would actually keep going with the applications. And the reason why I've said that is because this sodium is really high. 162 parts per million. It's at it's at 10%, nearly 11%, should be under 3. So that's coming from somewhere, and it's probably coming from your irrigation water. And so if that's always applying to sodium, we should always be applying calcium as the antidote to sodium. So calcium is your main antidote to sodium. So if it's getting applied, you want to put it on regularly. So that's why I've got lime by 2, gypsum by 3, but then still ongoing after that to deal with this sodium issue. I also put some Sulfix Mag in there, even though there was no initial recommendation. And the reason for that is because we're just borderline here in terms of the concentration. If we push calcium up from 37% to 70, it's a percentage. So as one goes up, another's got to go down. It's got to add up to 100. So as we push calcium up, it's actually going to push the magnesium percentage down. So knowing how that works, then I think we're going to need some magnesium at some point to balance that back up again. So that's why I put it in as well. Hopefully that's made some sort of sense. We've got 3 more to go through, which won't take as long as this first one. Before we get on to the next one, though, I just wanted to just quantify why I've chosen all granular amendments and I haven't looked at any sort of liquid options. If we have a look at our recommendation, which was 602 kgs of actual calcium, that's what we needed to apply. So the soil test, the base saturation method told us we needed to apply. If we apply a granular gypsum, and let's say we went out, which has got 23% calcium, and let's say we went out at 1 tonne per hectare, so we put 1,000 kilos out. So the actual amount of calcium applied, we applied 1,000 kgs of gypsum at 23% calcium. So we've actually applied 230 kgs of actual calcium per hectare. We have to get to 602. So to get to 602, that'll be 3 applications, and that might cost, you know, $3.5 or something like that for 3.5 tonne of a good quality gypsum. You get cheaper ones of that lower quality, but a good quality gypsum going out there. Let's say you try to do that with a liquid product. You know, so you're out there, you know, you got done your soil analysis and you've been recommended, oh yeah, you're low in calcium, apply this liquid. Most are sort of around about 5, 8, 10% calcium. Let's just choose one that's 18% calcium. You know, the rate might be 20 litres a hectare. Let's even go higher than that. Let's go 40 litres a hectare. So the actual calcium applied is 40 litres by 18%. We've applied 7.2 kgs of actual calcium per hectare. Only 7.2 through that liquid application. So the number of applications we need to get to 602, our target is 84. And you're never going to do it. Like, it's never going to happen. And that's not to say that liquids don't have a role in turf maintenance. They do. They certainly do. Liquids can supplement the plant. You can supplement a granular program. You can feed the leaf. You can apply iron, manganese, these type of things, biostimulants. You know, if you've got a known soil deficiency and you can't put a granular out there, you've got a deficiency in magnesium, and you know you've got that, but you just can't get a granular out there, then a liquid can compensate over the top. But it's never going to solve your soil issue. It's never going to change your soil analysis. In order to change your soils, you have to get the quantity on, and you only can get the quantity through granulars, and liquids are just a supplement to that. All right, soil test interpretation 2. We've got about probably 7 more minutes to go. So soil test interpretation 2, completely different look in soil test to the last one. We're going to go through the same process. Is there a soil imbalance? No, there's not. If we have a look at our actual versus our ideal, there's no soil imbalance there. Are there nutrient concentration deficiencies? Yes, there certainly are. All these are deficient. What's the TC/CEC? Low, 1.7. What's the soil pH? It's neutral. It's 7. So, which method should we use? Is the TC greater than 5 or 6? No. Is there a soil imbalance? No. And the pH is low? No. So base saturation wouldn't be the one to use here. You know, the slant approach would probably be more appropriate because we have a CEC less than 5 when the soils are imbalanced but the concentrations are low, and when the pH is near neutral, or neutral or near neutral, which it is, at 7.2. So the slant approach would be the most appropriate one in this case. So that's what's given us these numbers down here. And so we've chosen the slant approach, click that button, got those numbers. So now here's our available materials again, our gypsum, our lime, our dolomite, TX10, Activate K, Sulfix Mag and TX Trace. So what are we going to use this time? This is what I'd recommend. So we'd have gypsum at 500 kgs a hectare, and I've got it as ongoing because we've got a long way to go in this soil. You know, we've only got 230 parts per million, 238 parts per million calcium. We want 1100. We don't have the exchange sites to hang on to it yet, so we need to build those as well. And we've got to apply 1,287 kilos. One application at 500 kgs of gypsum will give you 100 kgs of calcium. And we've got 1,200 to get to, or 1,300. That's 13 applications. So this is an ongoing soil building program. Sulfix Mag at 300 kgs 4 times a year to get this magnesium up, as well as some exchange sites in the soil fix mag. TX10, that's the organic humus to get this organic matter percentage up a little bit without affecting percolation rates and our physical characteristics, which will give us the exchange sites in order to hang on to the calcium and the magnesium and the potassium. You know, Activate K, it's a higher K formulation. We need to get this potassium up as well. The TX trace element, get the trace elements up. So there's a lot of work to be done in this one. That is the actual root zone from that soil analysis. As you can see, it's a pure sand. Yeah, no exchange sites, no real humus in there. You apply nutrients, they're going to go straight through. So we've used the slant approach, but knowing that we can't put it all on at one time because it's not going to hold it all. So we need to build this over time. We need to build exchange sites, apply the nutrients, build exchange sites, apply the nutrients, build that root zone up over time to support the turf grass. Okay, soil test interpretation number 3. What do we got here? We'll run a bit quicker through these. Is there a soil imbalance? No. That's pretty much looking like that. Are there nutrient concentration deficiencies? Yeah, they're not dramatic like the last one. They are there though, but they're not huge. What's the CEC? 5.1. What's the pH? It's near neutral. Which approach should we use? If we have a look at the SLAN, the TEC is less than 5. Well, that's right on 5.1. So yeah, we don't know yet. When the soil is in balance, yep. And the concentrations are low. Yeah, they're lowish, but they're not too bad. But they are low. When the pH is neutral, near neutral, and that's where we've got our, you can see here 7.3%. So I'll be using the SLAN approach in this one. Available materials again. I would recommend this one gypsum at a tonne a hectare at renovation, and then after that go at sort of 500 kgs a hectare 4 times per year. We've got a bit to do here. We've got to get from this 713 up to 1100. So there's a bit of work to do there. I'll do soil fix mag to get the magnesium up, activate K to get the potassium up. We've got some good organic matter percentage. Our CCs aren't too bad. So yeah, it's just a matter of just getting those concentrations up. The ratios are fine. Click onto the next slide. So the last one, the final one. Here's our analysis result. What are we going to do in this case? Same questions. Is there a soil imbalance? Yes, there is in this case. Are there nutrient concentration deficiencies? No, not really. In terms of the actual raw concentration, 931 calcium, only just slightly, 165 magnesium, 351 potassium. So this is actually a sports field situation. This is what you might see in a proper soil, a bit similar to the last one actually in that case. They were both more soil root zones as opposed to sand profiles. So you might see it in a sports field rate, something like that, turf farm. What's the CEC? 11.4. So yeah, that's pretty high. What's the pH? 5.5. So that's acidic. So we've got a soil imbalance, and we've got an acidic pH. So if we have a look at the base saturation rules, when the CEC is greater than 5 or 6, yep, we're at 11.4. When there's a soil imbalance, yep, there's an imbalance. When the pH is low, 5.5, yes. So the most appropriate method in this one would be base saturation. And then that's what gives us, again, when you click that, our number down here tells us how many kilos of what nutrient to apply. So same materials, gypsum, lime, dolomite, so forth. Organic matter percentage is pretty good, nutrient levels are pretty good. We've just got this soil imbalance and this pH that's acidic. So this is pretty much the easiest one. It really just needs lime. So, I'd be going lime at half a tonne a hectare, and that's an ongoing process. Ultimately, to rectify this deficiency of 958, you're going to need 3 tunnel up. You know, in a turf farm situation, something like that, or you rode it home, yeah, you could go out your 3 tonne, bang, straight out. But in most maintenance scenarios, it's probably not possible. So you could go out a tonne at renovation and then go from there. But yeah, 500 kilos a hectare, do that over a number of applications, re-soil test, and then see how you look. So the final point I want to make, and appreciate your time, is once you have done a soil analysis and you've implemented a program, so you've spoken to your representative, you've spoken to your agronomist, and you've put in a program, the key thing then to do is to then monitor it and make sure that it's actually achieving what you want to achieve. And then through the analysis website, that's what you can do. So you can take tests and then do comparisons. And that's what this chart is trying to show you here, is this is a comparison chart over time. So what we've been looking at so far is just a soil analysis in isolation. So this is 3 comparative tests. So we're looking here, for example, at greens in March 2010, greens in October 2010, and greens in January 2011. And so going from left to right, you can see that we've gone from 779 parts per million calcium down to 532. So we're dropping, we're losing our nutrients. Our calcium's going down, our magnesium's going down. So we're not winning that race. So that then would instigate, okay, our program's not working, or haven't been on a program. We're going the wrong direction. We need to switch that around and get it going the right way. So that's what the power of the soil analysis can do, and those online analytical features can do, is that, you do analysis, set about a program, and then monitor to see how it's going and adjust as necessary. So that's taken us to the end of the presentation as it is. I've got a few question and answers and chats through there. Apologies, I couldn't do the answer the hand up. I did get one question there. Someone asked me, is high phosphorus a concern, and how do we lower? In some of those soil tests, there might have been some high phosphorus there. So that's an interesting question. You can't really lower it as such. Most of the phosphorus in soils will be bound up in unavailable forms. So ultimately, it's knowing it's there, knowing that you probably don't have to apply it if the phosphorus is high. You can do other tests to make sure that phosphorus is available. So you can do a saturated paste extraction, which actually looks at what's available in soil solution, or you can do a tissue test, and that actually tells you what's available in soil solution. So it's not about lowering so much. It's really just recognising it's not going to hurt anything unless it gets from 0 to 500 fast. It's not going to hurt anything. So I'm getting a few questions here, so that's all good. I'm figured out how to use that. So if you want to go to that chat or question and answer and flick some questions through on the question and answer, feel free to do that. And if you've had enough and you want to go, you can leave. But if you want to do some more question and answer, happy to do it. So Steve asked, what if you have a high percentage of calcium in the soil, but only low availability of calcium? Yeah, so that's similar to that phosphorus question, I suppose. You can have high calcium in your soil and low availability, and you'll get that quite often in calcareous sands. So calcareous sands, where the sand particle is actually made of calcium and magnesium carbonate, and you do a soil test, your calcium is going to be through the roof, but not much of it is available. That can also happen in where you're using bore water or effluent water. So bore water and effluent water, they have bicarbonate within the water. That bicarbonate reacts with available calcium in your soil and locks it up, creates calcium carbonate, calcium bicarbonate, makes it unavailable. So it might be there in your soil test, but it's not available. Again, you can do a saturated paste extraction to actually put it back in solution, to actually see, what's in solution. And you can do a tissue analysis to see what's in the tissue. Ultimately, often the resolution to that is to apply acids. So quite often when the availability of calcium is low, it's because it's bound up in a calcium carbonate form, which is lime, which is alkaline. If you add an acid to that, then the acid reaction to that fizzes, goes in solution, and then becomes more available again. So that's it. How to answer that one. So, okay, I've got the chat here. What would be the highest rate per hectare of gypsum and how irregularly? It sort of It depends on what situation you're in. So if you're in a golf green situation, at renovation time, probably 1 tonne a hectare. In maintenance, 500 kgs a hectare. Down to 200 kgs a hectare on a monthly kind of basis. If you're on a sports field situation or a racetrack, you can go up to 2 tonne a hectare, and be pretty comfortable with that. If you're in a turf farm situation and you're rotor hoeing, you can go up. I don't like to go any higher than 5 tonne a hectare in any one go. Guys have gone higher, but just don't want to put too much in solution all in one time. You might create some other issues and lockups. So in between those sort of rates, and second half of your question, how regularly, that's governed on your soil tests. So as we just saw before, the soil analysis would sort of give you a total amount of calcium, which comes from gypsum, that you might want to apply. So that'll give you an idea of, therefore, how many applications you're going to need. And then you do more soil tests, and you see whether you're going up, down, or not changing anything. And then that will kind of help you, in your assessments. I had another question here. There's a few questions in here. Okay, I'll work backwards. We should be doing water testing at the same time, correct? Yes, that is correct. Yeah, water testing, that's another whole presentation. So definitely should be doing, should be doing a lot of water testing, and because a soil analysis looks at nutrients in your soil. One of the biggest things that affects the availability of those nutrients in the soil is your water, is your irrigation water. So the chemistry of your irrigation water will have an effect on the chemistry of your soil. And if you don't test your water, then you don't know what effect that's having. You're just looking at a soil test in a moment in time. Water is the #1 thing that affects that soil test, whether it's high sodium, whether it's a water that strips all your nutrients, whether it's a water that locks up your calcium. You need to know that in order to make, obviously good recommendations. So yeah, certainly. So water tests should be done quite regularly at the same time. So that's a good question. Someone says I was muted. Hopefully everyone can hear me. Otherwise, this has been a long presentation with no sound. What do you mean by raising pH? So I'm not sure of that question there. If you have an acidic pH, so you're below 7, so you're at 5.5 or something like that, then if you apply lime, which is calcium carbonate, that will raise your soil pH. So therefore your pH will go from 5.5 up to 6, up to 6.5 to 7. So you're adding calcium, which is helping, and you're adding carbonates, which is also helping to push your pH up if that's what you're trying to achieve. Someone else said I was muted for a second, but then I came back, so great, awesome. All right, so another question up here, I think. Stephen, how much does a soil test cost for residential lots? Probably best to ring one of your reps, but a soil test, sort of costs around, up to $160, something like that. So, so just maybe give us a call and I can talk to you about that. Is there any other questions? We still have a fair few participants hanging around. So, as I said, my phone number is at the bottom there. You can ring myself, or you can ring any of the GDS representatives. They're obviously highly trained and all this sort of thing. So, they'll be able to help you out as well. So I think from there, we'll leave it. Again, appreciate your time. That was the first one that we've ever done. We're planning to run these regularly. We're thinking about weekly. We'll see how we go with that. The next one is going to be on colorants and pigments and using iron and manganese and the role of minor nutrients and colouring your turf, especially in winter. So hopefully that's interesting. And then if not, we'll have some after that from some other presenters that are experts in their fields, and we'll just try to get this rolling along. So thanks for your time, guys. Really appreciate it. And hopefully see you out there in the field. Catch you later.